Hey guys, in this video we're going to continue our discussion on linear equations. We're going to focus more on tables this time instead of graphs, but we're going to look at the connection between the three of these things: linear equations, linear tables, and linear graphs. And linear, again, just means line. So let's go ahead and get going. Now, we're going to talk more about this next time, but you should keep in the back of your mind, like, what could these linear equations with their inputs and outputs represent in the real world? Because they do represent things in the real world. There's a specific kind of situation where, that could be classified as linear. And I guess my question to you would be, what kind of situation is that? What kind of, when we have these inputs and outputs, like, what's the story that these linear equations are telling? So just recall that, linear equations with two variables, and you're gonna, next semester, my 1215, my Western people are gonna take 1215, and the first thing we're gonna talk about in 1215 are functions and function notation. And I'm trying to stay away from the word function because we haven't talked about it yet. But basically, a function it just has an input and an output. But I am going to just refer to what are known as functions as equations for the remainder of this course, just to not get you confused for now. So anyway, equations with two variables have an input and output. We typically represent the input with x, but we can really use anything to represent our input, and we usually represent the output with y. So give some inputs and outputs for this. Now, first of all, this is linear. We can see that this is in y equals mx plus b form. M is 3, B is 1, so it's definitely a line. When we make the shape of these inputs and outputs, it's gonna trace out a shape of a line. We know that for sure, just from looking at the equation. Now, for inputs and outputs, you always choose your own inputs, right? Choose your own adventure. If you wanna be crazy and put an input of 1,000,000, you can certainly do that. We talked about that last time, that lines have infinitely many points on them. We can choose, think of the number line. Think of this simple number line right here. Right? This is going to negative infinity, this is going to positive infinity. There are infinitely many numbers on this number line, and what's really interesting is that you can think of different infinities in different ways. So, like, if we consider the entire number line, not just numbers that you count with. Remember, numbers that you count with are just 0, 1, 2, 3, 4, 5, 6, 7, etc. And there's infinitely many of those. You can count forever and ever if you could. But there are also numbers that, there's an even bigger infinity to consider. And what that means, I'm not going to get into, but just to kind of, maybe pique your curiosity, if we consider the numbers between 0 and 1, there are infinitely many numbers, right? Because think about your fractions. We got 3/4, we got a half, we got, if you think about it in terms of decimals, we got 0.01, we got 0.75, which was 3/4. We got 0.6239421678 0.10568. Like, there's infinitely many numbers in between 0 and 1, and it turns out that set is considered a bigger set than the infinite counting numbers. It's really mind-boggling. And if you're interested in this, I know that this isn't what this video is about. I got off on a tangent, but you should look up Cantor. You should just Google Cantor and different sizes of infinity. It's really interesting. I mean, it kind of, defies our intuition, because you would think, well, this set of numbers between 0, 1, I mean, that is certainly have to be smaller than the set of counting numbers from 1, 2, 3, 4 all the way forever and ever and ever. You would think, but it's not. It's kind of wild. Anyway, I'm going to get off my tangent now. I may have had too much coffee before this video, and that is why I am saying all of these bizarre things. It's one of those days. But nevertheless, let's proceed with what we were talking about, linear functions, inputs and outputs. So give some inputs and outputs for this function. Okay, we make up inputs. That's what I said. So I'm just going to make up 3 of them, 0, 1, 2. Those are easy to work with. And outputs, we got 3 times 0, right? We're just plugging in the inputs into the rule to get y. So the rule says y is going to be 3 times 0 plus 1. 0 plus 1 is 1, okay? All right, the rule, when I put in 1 for x, I get y is 3 times 1 plus 1 is 4. When I put 2 in for x, I get y equals 3 times 2 plus 1 is 7. Okay, so these are my outputs, 1, 4, and 7. These are my inputs, 0, 1, and 2. And so what you want to, keep in the back of your head, we're not going to talk about it specifically this time, but think about what could this actually represent in the real world? Because it does. It represents, it represents certain things in the real world, and what specifically that is, you could tell a story about this. You could make up some things for x. Something happens when we plug in values for x. We get some rule that produces these outputs. We're going to, touch more on that in the next video, but just kind of keep that in your head when we're doing all this, because there's a purpose for it. There's real world implications, and if you study math further, I don't know, if you go on to like college algebra or calculus or something, the functions are, we study lines, but we study functions different from lines. We study curves, something like this maybe. That's going to tell a story, right? All of these graphs that we're looking at tell stories, and the first class of graphs that are coming up for you guys are lines. So anyway, okay, so here's the big idea. When you look at a table, you can tell right off the bat if it's linear, if it produces a line. And this is how you do it. When the x value increases by 1, the y value is going to increase by or decrease. I should actually put this, or decrease by a set amount. So for instance, if we look at these x values, notice that from each x value to the next, we're increasing by 1. To get from one x value to the next, we're always increasing by 1. Can you spot a pattern with the corresponding y values? What is happening as we move up down the y chart, or as we move down the y chart? So we start at 2, we go to 4, that's plus 2. We are at 4, we go to 6, that's another plus 2. 6 to 8, plus 2. 8 to 10, plus 2. So right off the bat, you can see this is linear. This produces a line, because when x increases by 1, y increases by 2. That's how you can tell if a table is linear. And if you were to graph all of these, if you were to, make a little coordinate plane here and plot all of these things, what you're going to see is a line. And it turns out that this guy is the slope of that line. And what would our y-intercept be? Our y-intercept would be this guy. That's when x is 0. By definition, our y-intercept is going to be 4. This thing's going to have a slope of 2. So it's going to look something like that. But yeah, that's how you can tell if it's linear. So let's do some practice here. Is the table linear? Well, if we look at our x's, for the first table, we're going up 1, 3 to 4 is 1, 4 to 5 is 1, 5 to 6 is 1. Okay, so we're increasing by 1. And then for my y's, 10 to 20 is 10, 20 to 30 is 10, 30 to 40 is 10. So yes, it is linear. As we're increasing by by 1 on the x, we're increasing by 10 on the y. So, yes. And our slope is 10, because that's how much we're changing by for every x. What about this one? So here we are from -2 to -1, we add 1. From -1 is 0, we add 1. From 0 to 1, we add 1. So we're increasing by 1 on the x, and for the y's, 3 to 0, we subtract 3. 0 to -3, we subtract 3. -3 to -6, we subtract 3. So yes, this is linear because now we are decreasing by a set amount. When x increases by 1, y decreases by 3. So that is our slope. Our slope is going to be -3. And what would our y-intercept be? Well, our y-intercept happens when x is 0, so our y-intercept here is -3. Now here we don't really know it, but we'll be able to figure it out, as I'll show you guys in a little bit. Okay, let's look at the next one. So here 10 to 11 is 1, 11 to 12 is 1, 12 to 13 is 1, and for my y's, -10 to -11, we take away 1. -11 and -12, we take away 1. -12 to -13, we take away 1. So we can see this, yes, this is linear. As we're increasing by a set amount, we're decreasing by a set amount on y. So yes, it's linear. And here, what's our slope? Our slope is going to be -1. What's our y-intercept? It's not obvious because we don't have x equals 0 on the table, but we'll figure out a way to do that soon enough. Okay, here, how about this one? So we're going up 2 to 4 is +2, 4 to 6 is +2, 6 to 8 is +2, and then for my y's, we're going up 4 to 8 is +4, 8 to 12 is +4, 12 to 16 is +4. Yeah, so, you know, if you were to expand this table, like 4 isn't the slope because we're not going up by 1s on the x's, but we can continue patterns, right? We can see the pattern that's happening here. When x is 2, y is 4, well, what's missing between 2 and 4 is x is 3, right? When x is 3, what do you think y is going to be? Well, let's fill in the missing information. So we have 3, 4, 5, 6, 7, 8. So we want the x values to increase by 1 to figure out what the slope is. So when y is 4, when x is 4, y is 8. When x is 6, y is 12. And when x is 8, y is 16. So we can fill in the pattern, right? You know, now we have that we're increasing by 1, so we can make a deduction about the slope. And you should think about why this is, why we're, you know, why we can only do this to conclude something about the slope. Okay, whatever. But what's the pattern? Well, the pattern is +2, right? To get from 4 to the next one, we could add 2 to get 6. From 6 to 8, we would add 2. From 8 to 10, we would add 2. 10 to 12 +2. And then 14 would be here. So the slope is actually 2. Yes, this is linear. So yes, this is linear because as we're increasing by 1 in the x direction, we're increasing by 2 in the y direction. So slope is equal to 2. Okay, so you always want to make sure these x's go up by 1 before you make a conclusion about the slope. Okay, let's look at the next table. So we're going up by 1, so 0 to 1, 1 to 2, 2 to 3. What's happening to the y's? Well, -4 to -5 is -1. We subtract 1 to get there. -5 to -1, we're actually adding 4. Uh-oh, so that's a problem. -1 to 2, we're adding 3. So these numbers are not the same, so not linear. We don't have a constant slope, right? We don't have, a constant rate of change here, so that's not linear. Okay, so again, I just mentioned, we've already talked about this. When you jump up by 1 for the x, the amount that you change for y is the slope. We saw that in all of these examples. So find the slope. We already did that, I think, for all of these. There's no slope here because it's not linear. Yeah, we already did that. Cool. So let's go ahead and write equations from tables. If we know the slope and the y-intercept, we can always write an equation, right? Our equation is y equals mx plus b. Anytime we know m and anytime we know b, we can write an equation. And we can always find b, even if it's not written in the table. And I'm going to show you how. Okay, so let's go ahead and first find the slopes. So for this first table right here, my x's are indeed increasing by 1, so I don't have to worry about anything weird here. What are my y values increasing by? Well, from 2 to 4 is plus 2, from 4 to 6 is plus 2, from 6 to 8 is plus 2. So my slope is 2. Excellent. What's my y-intercept? Well, my y-intercept occurs when x is 0. So my y-intercept is going to be y is 4. That's the point when x is 0. So b is going to be 4 here. And therefore, my equation is y equals 2x plus 4. Y equals mx plus b. That is the equation that represents this table. Alright, let's do the next one. So here I can see that I'm adding 1, so I'm not going to have any weird problems with the slope. So this is plus 1, plus 1, plus 1. If I look at my y values, 5 to 10 is plus 5, 10 to 15 is plus 5, 15 to 20 is plus 5, 20 to 25 is plus 5. And so we can conclude here that our slope is 5. Now our y-intercept occurs when x is 0. So that happens right down here. When x is 0, y is 20. So that's my y-intercept. Therefore, my equation is y equals mx plus b. Now when you're writing an equation, you always want to leave x and y alone, because y depends on x. If there was no x and y, we couldn't make predictions about the future. We couldn't make predictions about what happens when x is 3 trillion, right? That's the point. We want to be able to write a rule so that you can use the rule to make a prediction, okay? About something really, really far in the future. That's not obvious. Okay. All right, let's go ahead and look at these. So we have from 0 to 1 is plus 1, from 1 to 2 is plus 1, 2 to 3 is plus 1, 3 to 4 is plus 1. Okay. Now for the y values, from 2 to 0 is minus 2, from 0 to minus 2 is minus 2, negative 2 to negative 4 is negative 2, and negative 4 to negative 6 is negative 2. So negative 2 is my slope, right? Because as x increases, y decreases. So negative 2 is my slope. My y-intercept occurs when x is 0. So when x is 0, I see that right here. When x is 0, y is 2. So my b is 2. And therefore, my equation is y equals negative 2x plus 2. Okay, so we're going to assume that these tables are linear, all right? And we're going to go ahead and write equations for the lines. All right, so let's look at our x's first for this first table. So we're adding 1 on the x's, that's good. For the y's, 8 to 11 is 3. 11 to 14 is 3. 14 to 17 is 3. So 3 is my slope. And my y-intercept is when x is 0. So that occurs right here when y is 8. So b is 8. And therefore my equation is y equals 3x plus 8. Okay. Now, let's take a look at this next example. 0 to 3 is plus 3. 3 to 7 is plus 3. 7 to 10 is plus 3. Okay, that's no good. So we can't just we can't just deduce something about the slope because, it's not plus 1, plus 1, plus 1. You guys should think about why we can't do that. Why we can't make a deduction about the slope when that's true. However, we do know that this thing is linear. So, so we can't say anything about the slope quite yet, but we can see what the y-intercept is. The y-intercept occurs when x is 0, so that's right there. So for sure, b is equal to 6. The missing piece is our slope. Now, there's a couple different ways you can do this, but I think the easiest way is to just use the formula for slope. Remember, our formula is y2 minus y1 over x2 minus x1. We have ordered pairs. We have 1, 2, 3, 4 ordered pairs, so pick 2 of them and use the formula. I'm going to pick the first 2. So our first ordered pair is 0, 6. And our second ordered pair is 3, 3. So plugging these values into the slope formula, we're going to get y2 minus y1 all divided by x2 minus x1. So reducing that's going to give us a slope of -1. So that is our slope, and now our formula becomes y equals -1. We don't have to write the 1, we can just write -x plus 6. Okay. Alright, let's go on to the next one then. Okay, so we may have to use the same trick here because our x's aren't all going up by 1. The first thing we can do is we can see that the y-intercept is 2, so I can just write that down as like a note. But we need to figure out the slope, and we can do the same thing that we did before, where we do y2 minus y1 over x2 minus x1. Pick your 2 favorite points, it doesn't matter. How about I just do these 2 just to switch it up a little bit. My first point is 4, 4, that's x1, y1, and my second point is 6, 5. x2, y2. Alright, plugging these values into my formula, y2 is 5, minus y1 is 4. Oops. All divided by x2 is 6, minus x1 is 4. So 5 minus 4 is 1, and 6 minus 4 is 2. So my slope is 1 over 2. And I can write my formula from here. So my formula is y equals m x plus b. Okay, what if we aren't given the y-intercept in our table? How do we deal with that? So maybe think about this for a minute. Maybe pause the video and just kind of reflect on like what you would do. You shouldn't graph this. Like, don't try to graph this and see what it is, because that's just gonna take up some time. Too much time, I guess. What you can do is, what we're given, we're given a bunch of ordered pairs, we're given a bunch of inputs and outputs, and we can use the basic equation y equals mx plus b to solve for b once we have m. Okay? So, alright, so we're looking for b, we're looking for m. B is not in the table, but we can find m pretty quickly from the table. Notice the x's, let me do this in green. Notice the x's all go up by 1 as we move along. And as x goes up by 1, if you look at the y's go up by 2. So the slope is 2. Now how do we figure out b? Well, as I said, we're given a bunch of x comma y's, right? And the idea here is to plug in the x comma y, plug in the slope, and then figure out what b is from there, because then you just have numbers with, you have number equal number times number plus b, and we can figure out what that number is. Okay, so let's pick a random ordered pair on here. It doesn't matter which one you pick. I'm going to just choose this one just because. So there, x is 6, y is 8. You could have also chosen this one. You could have said, well, x is 4, y is 4. Or you could have said x is 3, y is 2. It doesn't matter. Just pick one of the points. So we know this. We also know from what we just found that m is equal to 2. So if I replace these things in this basic form, I get y is 8, m is 2, so we have 8 equals 2 times x is 6 plus b. Now b is a variable. This is just an equation. We're just trying to solve for b. So on the right side, 2 times 6 becomes 12, so I have 12 plus b equals 8, and I can get b by itself by subtracting 12 from both sides. And I get b is equal to negative 4. So there it is. We have b is equal to negative 4, m is equal to 2, so our equation is y equals 2x minus 4. All right, let's do some problems here. We're going to assume that each of these, if there's a table given, that it's a line, it's a linear table. So if we look at our first question, we're trying to find the equation of the line, and that consists of finding m and finding b. If we know these two things, we know the equation. So if I look at this first one, the x's are all going up by 1. And as x goes up by 1, what's happening to y? 0 to negative 4 is minus 4. Negative 4 to negative 8 is negative 4. Negative 8 to negative 12 is negative 4. Therefore, our slope is negative 4. And our y-intercept, we're not sure what it is yet because we don't have x being 0. So we need to figure it out with the way that we did this last problem. So pick any xy. Pick any pair x comma y. I'm going to pick the first one. It looks easiest. When x is 4, y is 0. And plug this stuff into your basic equation. Okay? So we're looking for b. We know what x is. We know what y is. We know what m is. So we have y is 0 equals m, which is negative 4, times x, which is 4, plus b. Now on the right side, we get 0 equals negative 16 plus b. And then if I isolate b, I can add 16 to both sides to get b equals 16. So there I have it. I am done. I have m is negative 4, b is 16, and therefore my equation consists of these two things. Y equals m, x plus b. And that's my equation. Okay, let's try the next one. So this line passes through this point and has a slope of negative 3. So this point is an x comma y. It's an input comma output. So we know from this clue that x is 2 and y is 6. We also know that the slope is m, so m is negative 3. And again, we're trying to figure out what b is. So y equals mx plus b is our basic form. Let's go ahead and plug all of these values in to our equation. So we have y is 6, so we have 6 equals m times x plus b. On the right, we have negative 3 times 2 is negative 6 plus b. And then I'll add 6 to both sides to get b equals 12. I'm trying to fit it all in that space. But b equals 12, m is negative 3. Therefore, our equation is y equals negative 3x plus 12. Okay. Alright, so here we aren't given anything. We're not given a slope or a y-intercept, but if we're given 2 points, we can find everything that we need. So first, our slope. Well, since we're given 2 points, we can use the formula. We can say this is our first point, x1, y1, and this is our second point, x2, y2. So our formula tells us y2 minus y1 over x2 minus x1 is the slope. Plugging our numbers in, we get 4 minus 2 over negative 1 minus a half. Okay, on top, 4 minus 2 is 2. Negative 1 minus a half is negative 3. Let's see. Yeah, negative 3 halves. I can make this a little bit simpler by keeping the top multiplied by the bottom flipped. Multiplying straight across, I get negative 4 over 3 for my slope. That's my slope. Alright, now, I have a slope, I have points. Now, this is a relabeling. I don't have to call this point x1, y1. It's still an input and an output. I don't have to call this one x2, y2. It's still an input and an output. So, again, we want to use the trick where we have that equation and we can just plug in some stuff to figure out what b is. We have an x comma y. We actually have 2 of them. Pick one of them. Doesn't matter which one. I'm going to pick the second one because there's no fraction. In that second ordered pair, my input x is negative 1. My output y is 4. And we just found our slope to be negative 4 over 3. So using all this stuff, we can go ahead and plug this stuff into our basic equation. Y equals mx plus b. So here, again, I'm replacing y with 4. And again, you could have used 1/2 for x and 2 for y, but why deal with a fraction when you don't have to? Alright, so we have y is 4, m is negative 4 over 3, x is negative 1, and we're trying to find b. So multiplying on the right side, negative 4/3 times negative 1 is going to give me a positive 4/3 plus b. So I ran out of room here, but I'm going to subtract 4/3 from both sides. So 4 minus 4/3 is going to give me, let's see, that's going to give me 8/3. So b is 8/3. Okay. Now that I have the 2 things that I needed, I can write my equation. So my equation is going to be y equals m x plus b. And that is my answer there. Alright, let's look at the next one. Again, we're passing through 2 points. So let's go ahead and label our points x1, y1, x2, y2 so that I can find the slope. Okay, so the slope y2 is 9 minus y1 over x2 minus x1. Alright, these double negatives on top and bottom become pluses, so this becomes 9 plus 3 over 2 plus 1. So that's just 12 over 3, which is 4. So that's our slope. Our slope is 4. So that's one piece of the puzzle. Now we need our y-intercept b. So to find b, we choose one of these points and do a relabeling, right? Because x1, y1 means the same thing as xy. It's just you're renaming your input and your output. I'm going to use the second point as x comma y. So x is 2, y is 9. And then I'll just plug all of this stuff into my basic my basic formula y equals mx plus b. So y is 9. Let's write it over here. We have y is 9, m is 4, x is 2, and b we're trying to find. Okay, solving for b. On the right, if we do 4 times 2, we get 8. 8 plus b. And then if I subtract 8 from both sides, I get b equals 1. So now I have everything that I need. B is equal to 1, m is equal to 4, and I can write my equation, leaving x and y alone, thinking about the bigger picture that we want to use this formula to find not so obvious values of x and y. Alright, so our formula is going to be y equals 4x plus 1, mx plus b. That's our answer. Let's do one more. Passes through this point, has a y-intercept of 10. So this time we're being told explicitly what b is. B is 10. It's our y-intercept. Now we need to find the slope. Now what is this? Passes through. That's an input-output, so that's an xy. So again, we have our formula, and we can't do y2 minus y1 over x2 over x1 unless you want to write the y-intercept as an ordered pair. You can definitely do that, but anyway, so we have y equals mx plus b, and if negative 1 is y, b is 10, and x is negative 2, we have negative 1 equals m, which we don't know, times negative 2 plus 10. So I'm just plugging in everything I know for x, y, and b, and I'm solving for m. So the first thing I can do to get m by itself on the right is I can subtract 10 from both sides. When I do that, negative 1 minus 10 is negative 11 equals m times negative 2. So to get rid of multiplication by negative 2, I need to divide both sides by negative 2. And the 11 over 2 doesn't simplify, but the double negatives do become a positive. So m is equal to 11 over 2. And now we have everything that we need. So our equation is going to be y equals m x plus b. And that is our answer.